Okay. Dear students, you are welcome in this class, and we continue the same topic. And today we will see applications of correlation and regression analysis in your research. Whenever you do your MSc research, you make your thesis or you write your thesis, and you also write some papers. And this correlation and regression analysis, if you can learn, you can use this knowledge to your research very well. And I assure you, if you understand it, it will add value to your work, value to of your research work. And new interpretations can be brought out if you use this knowledge. Statistics is used in agronomy for testing the significance of treatment. And after that, very rarely people use statistics. But this correlation and regression analysis starts where your conventional analysis, conventional statistical analysis stops. So if your F test is significant, as I already told you, you will compare the treatment, but you can also do correlation and regression analysis. I am showing you certain examples. You just see on the screen, it is a research paper published in Agronomy Journal. Agronomy Journal is a high-rated journal published by American Society of Agronomy. Many of you might be knowing it. So in this paper, this is published in 2020. You can see they have used this, this knowledge, means regression analysis. They have regression lines. You see picture number 1. On x-axis, you have nitrogen application rate and nitrogen available from the soil. So you can see 0, 50. These are levels of nitrogen. You can see on y-axis, it is grain yield. It is not really rocket science. They have simply developed some regression equations or regression lines, and that have been represented in this picture. So you can see there are two lines. One is solid line, other is dotted line. This solid line represents a particular source of nitrogen, NBPT, and then another source in dotted line is urea. So here you need not to understand what are the results. You need to understand how results are presented. The results are not important in this case. Don't concentrate on the results. Concentrate on the way they can be presented. So in this case, it is very simple that you have application rate of any nutrient, any herbicide having increasing levels, having quantitative data. So you can plot it against grain yield. You can plot it against harvest index, against anything. You can plot it. So you may consider the variable on y-axis as dependent variable. On x-axis, you can have independent variable. So in this case, two sources have been compared. However, you can also compare 5 varieties. In one graph, you can have 5 lines for 5 different varieties. However, the levels will remain the same and grain yield will vary according to the variety. So this is how you can use this knowledge. Wherever you have question, you can stop me. Now see another figure. Same way, they have used similar kind of data. In this figure also, nitrogen, and maybe at different locations. They are at different locations. Now see another picture. Here also you get nitrogen applied on x-axis. What was the rate of nitrogen application? And on y-axis you have nitrogen recovery. So here you can have nitrogen recovery, and you can interestingly very clearly see that there is negative relationship. There is negative relationship between nitrogen application and nitrogen recovery. So in place of nitrogen recovery, you can also take agronomic efficiency. On the right side, you can see it is agronomic efficiency. Then you can change the parameter, physiological efficiency. You can take any other variable. Even you can take plant height here. You can take leaf area index. The thing of your choice you can take on y-axis, and you can develop the relationship. Even you can find the relationship between dry matter production and plant height. Dry matter production and leaf area index. Are they related or not? Are they related or not means you need to calculate the correlation coefficient. And what is the nature of relationship? How quantitatively they are related. For this, you can fit the linear equation or quadratic equation depending upon the significance. Now see, optimum, this slide is really not very clear, but it is not just fertilizer. You can take other inputs like plant population, seed rate, or some other variables you can take. And you can see the equations here, quadratic equations have been developed for calculating the economics of seed rate. What is the optimum level of seed rate? You can calculate it. You can do the economics also. So there are different locations, and you can see the quadratic equations. Quadratic equations here, they have been developed. And you can see this is your A, y is equal to A plus bx plus cx square. So this is your A, this is your B. Value of B is 1.065 and value of C is minus 104. So this is your equation, and it is significant at probability less than 0.01. And agronomic optimum seed rate is 5.12. So you can see the seed rate has been, optimum seed rate has been worked out by quadratic equation. Similarly, here it is correlation between.
Sir, what is P, sir? P value, it is stable value, sir?
It is probability at which it is significant. It is actually level of significance. Here less than 0.01 means it is multiplied by 100. So it is significant at less than 1% level of significance. It is 0.01, you multiply it by 100, it is 1%, and 1% level of, it becomes your level of significance, means probability of significance. Probability or level of significance is, in this case, less than 1%. Did you get it?
Yes,
you
sir.
have level of significance 1%, probability of significance actually. Probability of significance. So this is significant at 1% or less than 1%. If it is significant at 1%, then it is significant at lower levels also, less than 1%. So now in this case, significant regressions between plant variables and K fertilizer application rate. So K fertilizer application rate is your independent variable, that is your X. And Y, you can assume Y as plant diameter can be Y, plant height can be Y, dependent variable. So you can take one by one. So suppose your plant diameter is a dependent variable which is dependent upon K application. So in this case, forget about probability. Just you see the equation. So this is the relationship between K application and plant height. You can test it for linearity, test it for quadratic equation, and then it is quadratic equation, and then R square is 0.53. So you can see value of R correlation coefficient also. So this is how this knowledge can be used to develop relations between independent variable and many dependent variable, one by one, and you can do it together also. See the last line on the bottom, biomass K uptake is, you see, it is linear relationship, means your, as you are increasing the K levels, potassium levels, the biomass uptake of potassium, in biomass is increasing linearly. But in some cases, you find linear relationship between two variables, and in some cases, you will find quadratic relationship between two variables. See this case seriously. Sorry. This is work by our student Habibullah Kashiri, who was from Iran. So in this case, just I wanted to show you how best you can use this correlation coefficients, how to make practical use of correlation coefficients. So in this case, just I want to show you variables. This ammonical nitrogen was measured, and also nitrification rate of nitrification. These are two variables. Just consider them as two variables. One more variable is DAI, days after incubation. So you can see the relationship between the status of ammonical nitrogen and nitrification rate. Here you are not understanding what is ammonical nitrogen in soil or what is nitrification rate. Here you are understanding that how these variables can be related to each other and how to do interpretation. That we are learning here. We are not learning chemistry or soil science here. So think that there are two variables and which are opposite to each other. If you have a higher ammonium level, that means nitrification rate is low. If you have lower ammonium levels, that means nitrification rate is high. Similarly, in case of nitrate and nitrification rate, NR is your nitrification rate, they have positive correlation. But here correlation is negative. So you can see at 75 kg dose, it is minus 0.99, minus 0.99. So that we can work out the significance. I have told you how to calculate the correlation coefficient. We can calculate the correlation coefficient and see they are significant. If they are significant at 5%, put 1 star. If they are significant at 1%, then put 2 stars. There is some mistake in the bottom here. So another case where we can use this knowledge correlation. This is our paper, and based upon this paper, now you have neem coated urea in the market. The 360 ppm came from this paper. It's not very clearly visible, but you can see the first column, treatment, 0, 500, 1000, 2000 ppm. This is the dose of neem oil by which prilled urea was coated. Coating was done with the prilled urea. Now you also have the levels of nitrogen, 0, 50, 100 and 150. So these levels of nitrogen were coated with this much of neem oil. Now you want to test their significance of these treatment. Then we can make quadratic equations, linear equations, and then the coefficients can be used as SEM, as your CD or LSD. Critical difference, instead of critical difference and LSD, least significant difference, we can also use these equations. Here beta 0, you can see it is the intercept. It is the intercept, yield at control. You can say yield at control or any dependent variable. Beta 1 is your actually B, regression coefficient 1. And then beta 2. Beta 2 is C, regression coefficient number 3. And these two values can be used to compare these treatments. If you want to compare control versus rest, use beta 1. If you want to compare within the levels 500, 1000, 2000 ppm, then you can use beta 2. Beta 2 regression coefficient can be used as your CD or LSD. So such kind of interesting manipulations can be done with your simple agronomic data. I'm just telling you the scope. Now you see on y-axis, x-axis, you have the dose of neem oil per kg urea and grain yield on y-axis. And you can plot for different years. This data pertains to 2 years. Now, you can also do regression analysis of nitrogen uptake versus grain yield. So these are different dimensions where you can use. For example, if you are a soil scientist and you got pH value in soil, that these are 5 different pH value, 5 soils of 5 different pH. Then you can analyze the nutrients. How much is phosphorus, how much is potassium, how much is carbon, and then you can relate them. You can do correlation analysis there also, correlation and regression analysis On one side, you can make any variable as independent variable and any variable as dependent variable. And you can see the relationship between any two parameters. You can take bulk density or bulk density with your nutrient content. You have 5 different soil where 5 different bulk densities are there. So you can make relation between bulk density and water retention, bulk density and NPK, whatever you like. It's very interesting area where you can see relationship between any two variable of your choice. So here N uptake versus grain yield. So in this case, the relation was linear. It was linear relationship, you can see. Means as you increasing N uptake up to 150 kg, your grain yield is increasing. Beyond which we don't know, because we have not tested levels higher than 150 in this case. Now, similarly, neem oil, you can see here on the bottom, you got neem oil and you got ammonical nitrogen. Ammonical nitrogen means any variable here, and you have 4 different types of soil. They can be 4 different varieties. They can be 4 different sources. So you can take anything here. And equations are developed. R square is also given. Likewise on the right side. So this is just to show you that this knowledge is very, very frequently used by scientists. You can see some negative relationships can also be there in the variables.
Sir.
Yeah.
Sir, please show the previous slides. Sir. Sir, if these four variables like different types of 4 types of soil or 4 types of variety are taken, then the relationship between neem oil and ammonium nitrogen will be same. Is this relationship will be same?
No, it will vary because response will vary in different soils. In different soils, one is coarse textured soil, one is fine textured soil, other is medium textured soil and sodic soil. So you can see in different soils, for example, in sodic soil, you got lower levels of ammonical nitrogen. And then pink one is your medium texture soil, red one, pink one. So you get different response. Their responses are different. You can see their curves are different. Some curve is going up to 120, you see yellow one. And blue one, the highest data is somewhere between 80, 90. And in case of pink one, it is 70. And in blue, it is 60. So responses are, here the responses are different. Responses can be almost similar and they can be different also.
Sir, can this response will always be quadratic or maybe linear also, sir?
See, very good. So in this case, the fundamentally, I taught you that you should start with linear. First of all, we should test linear. If it is linear, fine. If it is not linear, it is proved. I have shown you how to test the linearity of the equation. If a linearity is significant, means it is a linear relationship, then we need to go for linear fitting of the equation. If it was non-significant, means it was not linear, then we go for quadratic. If quadratic is proved to be significant, then we can develop the line, we can develop the equation. If your data are non-significant, if your equation is not significant, you will not get good results. I tell you one story. One student has, actually the relationship was linear, but by force, Jabardasti, he fitted quadratic equation. And then the optimum dose went beyond the highest dose he has tested. Suppose highest dose he has tested 150 kg and his optimum dose come out to be 180. How it is possible? So you need to choose right equation. It is also important, and significance can be tested. I have shown you in both cases for linearity, for quadratic. And if you do not know, today I will show you how to do it in Excel to save your time. Now people are using softwares, but I tell you, we should know the background. We should know the theory of the things. So your answer is that first you test for linearity, If non-significant, then you are supposed to go for quadratic. If quadratic is also non-significant, then go for cubic, and so on. If cubic fail, then you can go for other kind of equations, like your exponential equation, like your log transformation, and so many things are there. If one is interested to fit equation, data, graph, chart, then you have so many options available. Transformation of data is also available. But those are very advanced things that we need not to learn at this stage. Is it clear, or you have any other doubt? Ask me. If you have any doubt, don't.
Hello, sir. Hello, sir.
Yes.
Sir, I want to ask whether we test the our equation. We generally consider the significance level 1%, sir. Yeah, maybe 5%. Either any standards, or we take only 1%, 5%. Yeah, other things.
See, people have made a lot of work in field data. In field data, where we get more variability in the data, more coefficient of variation. In those cases, it is always 5%. 5% is the ideal level of significance. 5% is recommended for most of the field studies or port studies. But for laboratory studies where you have control over the error, there are two kind of errors: assignable, non-assignable. So if you have under controlled condition, under laboratory condition,
So it may be gone for the preparation of this that strategy.
Where you have typical experiments under controlled conditions, science experiment, there it is 1%. Yes, somebody else is also asking. Yeah, any other question?
No, sir.
No question. Okay. So you can see this. Line कैसी आ गई है? Anyway, why this line is coming, blue line? Z. अरे रूस का कौन आ गया यार ये? So just let me reshare it. The Z किसने बना दिया भाई? Who is supporter of Russia?
No.
No one, sir.
Z बन गया था, किसी ने बनाया था. Anyway.
Zoom वाले ने सर.
Zoom वाले ने बना. So can you see the slides moving?
Yes, sir.
Okay.
Yes, sir.
So see, there can be negative relationship also. So see this this paper. In this paper, on x-axis we have levels of zinc, different levels of zinc. On y-axis you have grain yield. In both the figures, their years are different, first year and second year. So here you can see that this blue one is your observed data. These data are your from the field. And this red line is the fitted line, regression line, which is written here quadratic. It is quadratic regression. On the right side also, you can see the same data. And it was done in SPSS. There are some softwares like SPSS, statistical software. SAS is also there. There are many others. So you can see one interesting thing here, that in this case, you can see it is not a good fit. Some data is away. Some data is still away from the main line. So you can see there is some wrong fit here. However, in other case, you can see the data are overlapping to each other. So you see R square. Here R square is 0.991. And in this case, it is less. So this is the reason that your R square will tells us the fitness of the equation, how fit it is, how best we were successful in fitting the data. Now some more data, you got negative relationship like nitrogen use efficiency and fertilizer rates. So here zinc rates are increasing. Your partial factor productivity and agronomic efficiency, they are decreasing. So inverse or negative relationship. Now, friends, it is not me, it is everywhere around the world. And this is the paper I shared before. In the forenoon, I have shared this paper, whole paper published in Agronomy Journal. It deals with these kind of figures only. There are hardly 2-3 tables in the paper, and there are at least 15 to 20 figures like this, regression analysis, and very simple, and it is published in Agronomy Journal. So you can see on x-axis, simply nitrogen rate, what I am teaching you. On y-axis, you got grain yield, and you got two different sources, PCU, prilled coat, what is this? P is polymer coated urea and simple urea. They compare two sources. So here red one is for polymer coated urea, and this blue one is for urea, and one is linear plateau. So you can see that this knowledge is also used here, and so many examples are there. And this is relative efficiency of sources. So in this case, you can find the optimum dose of the fertilizer. So here you see the first table, response equation, economic optimum dose, yield, and response of wheat at economic optimum dose. So you can see there are three different sulfur sources, and these are the equation, quadratic equations for three different sources. In one source, the optimum economic dose was this one. These were different doses for wheat crop. And similarly, yield at economic optimum dose, kg grain per kg sulfur. So this was the yield at optimum dose and response at economic optimum dose. Yesterday, I have told you how to calculate the responses and economic optimum dose and so on. And on the bottom side, you see this is for another crop. So here you can see very interesting information may come. For example, if you have phosphate as a source of sulfur, then optimum dose is 20. If you have elemental sulfur, then optimum dose is 38. If gypsum, then optimum dose is 45. So it is really very interesting result. It is giving you very good information if you have different sources, and it was tested in one experiment. So it is also giving you responses. And this is not a joke. It is published in some good journal. You can see it. So it is very simple thing, simple aspects. And if we use this knowledge, our paper or work will be appreciated. Now the main thing starts here. Up to now, I just wanted to show you importance of this subject. Now, using Excel for correlation and regression analysis, we will start it. What we are going to do is compute the correlation coefficient of pair data from the experiment. In correlation regression analysis, data is always in pair. One is independent variable, other can be dependent variable. There can be many independent variable and one dependent variable. So then fitting of regression equations, I will teach you how you can fit in Excel, and then how to test the significance of equation. Somebody was interested to know about it. So I will tell you how to test the significance of linear and quadratic equation or cubic equation. Then how to plot these equations in Excel, and how to work out the optimum economic dose of the fertilizer. So many things we are going to learn now, but it is the time to change the link. 1 minute is left. So now we are going to learn, and in the very beginning, your job is to install the data analysis pack. Data analysis pack is always there in all Excel programs, but many times it is not installed. You can check your Excel program in your computer, in your laptop, wherever you have Excel. You can check when you open the Excel, you can check whether you have data analysis pack or not. So data analysis pack, you can see here red arrow on the left direction. So it should be seen in your Excel. So many times it is not seen. If it is not seen, means you should click the data. When you click the data, on the right side, you should see this data analysis tool pack. It should be there. If it is not there, then you need to install. And it can be automatically installed in your software, in your Excel program itself. You need not to buy from outside. You just need to install, which is already there in your computer. So how to install it? When you start your computer, go to File. When you in the Excel program, you go to File, click on File, number 1. Number 2, you select your add-ins. Add-ins, I think you are new generation. You know add-ins, you are going to add something. So select the add-in. Number 3, in this, when you select add-in, you will get this select analysis tool pack, this blue color. Then you select this. And number 4 is click on Go. On the bottom side, you will get Go. If you click it, it will ask you again what you want to install. There may be several options. You click on data analysis tool pack. You select the data analysis tool pack and click OK. So your data analysis will be installed. So once your data analysis is installed, you can do a lot of data analysis in that. Now I am telling you, discussing with you, if you have Excel program, in Excel program, you want to fit a linear equation manually. You want to do it manually without using formula, without taking help of any formula from Excel. Then you can do it very easily in your Excel. So this is your independent variable, this plant height. You can take plant height as independent variable. Suppose you give it name as X. Then fertile tiller. Fertile tiller is number of panicles per hectare or per meter square, whatever you like. And you can consider it as dependent variable Y. Okay, so now you have pair data. This is pair data, and there are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pairs are there. So in total, you have 12 pairs. And then what first you need to do, you need to take the deviation against the mean, X minus X bar. So you can take the mean of X, mean of this data you can take, which is 87.9. So you take this 87.9 and subtract it from 82.2, 100.2, so that you get these values. I think you understand it. It is very simple. And similarly, you have Y. Take the mean of Y, 509, and subtract 509 from 495, 650, 450, and then you will get these values. And you know it is going, total is going to be 0 because you are taking deviations against the mean. Now you can, in Excel, you can very easily square this column. This small x, this is small x. So you can square these values, so you will get these squares and make the total. This total is your summation x square, small x square. Then your total sum of square is small y square. You have this column, square these values. No, summation y square. Where is your y? This.
The right side of X.
Yeah, y. This is your y. You square these values, you will get this column. And make the total. This will be your summation y square, 83,542. Then cross products xy. Xy means this this column and this column. Multiply these two, and all values will be here. And then you get total of this summation. So I think you know that you have all these summation xy, summation x square, summation y square, summation x square. So from these, you can calculate the value of B and A very easily. And then you can put in the equation. And you can also calculate the value of correlation coefficient like this. And you can square it to make coefficient of determination. So any problem in this simplest exercise? in Excel if you want to do?
No, sir. Just one problem is there, sir. When I was doing, when we are taking the minus mean from the x or y value and dragging, then in dragging we shall do one by one, sir. G. And dragging it varies from one another, sir.
You are right. You are right.
And dragging a minus in plus in we will get wrong values, sir.
Yeah, dragging.
Dragging.
Yeah, you are right.
Just in these two columns, sir.
Actually, why I did it because Excel, or many times this Excel is not working in Zoom. I tried sometimes back. I wanted to demonstrate live to the students, but this Excel did not work in online Zoom for me. I don't know. Can I try it now, or what is your idea? Can we demonstrate live Excel through Zoom? Anyway.
Yes, sir, you can, sir.
Okay, but I was thinking, otherwise, why I did so much of hard work? It took me 1 day or 1.5 day time to take screenshots and make this presentation. Anyway, I was not knowing that. But sometimes back I tried and I failed. I don't know reason. Anyway, now you see, this is a problem. A field experiment on fertilizer management was conducted. Data on growth parameters, yield attributes, grain yield, and harvest index were recorded. Compute the correlation coefficient among different parameters studied and test their significance. So this is very simple problem you are going to solve in Excel. So this is your end rate, 0, 20, 10, 20, 30, so on. So here, this is your independent variable, and all others, they are dependent variable. And in Excel program, you can very easily know the correlation coefficient together. You need not to do much exercise. You can do it in Excel. If you do in manually, then it takes a lot of time. So because first you will do it for end rate, plant height, then end rate, fertile tiller, end rate, so. And if you want correlation coefficient between two variables, these two variables, then also any two variables, then it takes a lot of time. But in Excel, it takes seconds. So how to do it in Excel, I want to tell you how to find out correlation coefficient matrix. People call it correlation coefficient matrix. So by that way, how to do it now? So you have this same data here. In the last slide, you have seen enter the data in the following format and select all. So you can select all data. And then on the right side, you go to the right side, step number 1, click on data analysis. If you click on data analysis, you will see this window. This will pop up. And here you can select correlation. Simply select the correlation. And number 3 is press OK. When you press OK, what you will see? You will see like this. One more window will come. This is your data already selected. And here input range. Input range means this selected data. This data. So here you minimize it. Click here. It will be minimized. And then again you select this data. Select all the data. And then click here and maximize it. And also, if in the first row, if you have like names like this, end rate, PHH, labels are there, then you tick it. You tick this one, so that computer will not read this as numerical data. It will read it as labels, the names. So you can see you have minimized it. After minimize, select the data to input range. You can select and then again click here. After selection of data, click here the input range to maximize it. And when you maximize it, it will look like this. It will look like this. And then what you need to do, you can tick labels in first row, number 1. Number 2, click on the output range. So output range, whether you want your result right in the same Excel sheet or you want new worksheet. So it depends where you want to save your result. So 3 options are there. Normally people take output range. So on the same file and same page, if you want result, output range, minimize it. Click here to minimize and click here to maximize. Click to minimize output range. Now, the output range would look like above after minimizing. You minimized it. Now you select this area. You can select the area. It is minimize output range and select the space. Suppose you want result here. So select only 2 cells, 3 cells only. Number of cells is not fixed. You can come and select any area. Just you put cursor and select 1 or 2 cells or 10 cells. Any number of rows or column you can select. It is just indicative. So it will give you result here in this part. Then again you can click it here and maximize it. So click here to maximize it. And then you are doing correlation analysis. So here it is correlation is already written and you maximized full size. Now you see your output range is there, your input range is there. This was your input range and click OK here. If you click OK, the results are there before you. So results are in this form. So these all are your correlation coefficient. All are correlation coefficient. If I want to know correlation coefficient with the same variable is 1. You see this is 1, 1, 1, 1. This is, you ignore it. It has no sense. It is not relevant. But if you want to see correlation coefficient between plant height and fertile tiller, suppose fertile tiller. So plant height go down and fertile tiller. So this is the correlation coefficient for these 2 variables. Suppose you want grain yield with spike length. SL is your spike length. So SL you go down and grain yield is somewhere here. So this 0.172 is the correlation coefficient between these 2 variables. So what is there? It is two-way. The same parameters are written this side also, so that you can very easily know the correlation coefficient between any 2 variables. These are just indicative. Don't go into the science of this with these variables. Means you can have any variables here, and you can know the correlation coefficient among themselves. Now, now you need to see the significance of these correlation coefficient. I told you 2 methods. One is t-test, other is R-table. Tables are available by R.A. Fisher. So it is your choice. But most of the software, like your SPSS says, they are giving you significance also. They will put the stars automatically here. But Excel is a free software. So therefore, such facility is not available in the Excel. You have to put money or you have to put your hard work. It is your choice. So what we can do, we can put our hard work. And this is another example. This data is from another example. And you can put some, is it the same? Yeah, it is the same data. Same data, 0.483. Yeah, it is the same data. Only difference is, yeah, to make more clarity, I just removed 2 places after decimal from the right side. So because there are so many places after decimal, it makes no sense. So normally correlation coefficient up to 3 digit is perfectly okay. So wherever minus is there means these 2 parameters, for example, fertile tiller and N rate, they have negative relationship. So it is the meaning of this. And now you want some correlation coefficients to see the significance of the correlation coefficients. To see it, you need to put this correlation coefficient like this. This data is from another example to test the significance of R. So first of all, you need to work out the degrees of freedom at which you will see the table value of R. So degree of freedom here is n minus 2. So there were 12 pairs. So 12 minus 2, 10 is the degree of freedom. At 10 degree of freedom, you can see 10. At 10 degrees of freedom, a critical value of R or table value of R at 1% is 0.708. At 5%, it is 0.576. Normally or always, you get higher values at higher level of significance and lower values at lower level of significance. So you can see, you can put 2 star if your values are significant at 1% level, and 1 star if your values are significant at 5% level of significance. This is a usual representation by statistician. So now you see, normally if we see at 5%, then the values of the correlation coefficient, irrespective of their sign, whether they are positive or negative, the same R value will work. This minus sign is not absolute. It is just indicative of the kind of relationship two variables have, or it tells the direction of change. So same will be used for minus values of correlation coefficient and for positive values. So suppose you are seeing for 5%, 0.576 is the value of table value of R. So values here, which are more than 0.576, are significant at 5% level of significance. So you can put 1 star there. Number 2, values which are higher than 0.708, you can put 2 stars on that. So according to this, you can see which correlation coefficient are significant, which variables have significant relation, or which do not have. Any questions from this?
Sir, these star we have to manually or any software?
Yeah, actually, right now we do not have choice. If we are doing in Excel, we have to do it manually. But if you do the same thing in SAS or SPSS or any standard statistical software, they will automatically give you stars. You need not to do anything. Okay, but in Excel, because it is free, these softwares many times they are not in our reach. So what we do, we are bound to do it. So it depends upon your facilities and choice. Any other question? Now this is your homework, same exercise you need to do yourself. It is for practice. It is up to you. If you want to learn, you can do it. If you don't want, it is up to you. But I would recommend that you practice it in Excel. Because I have already shared this presentation in PPT form. So you can select all data, copy them to your Excel and do analysis same way. Practice it one time in your life. If you can practice it, then in future you will be able to do it at your own. And you can also learn from each other. So here N is 7, because if you count treatments 1, 2, 3, 4, 5, 6, 7. So there are 7 pairs. And on one side you have this, these are the nutrient sources, and these are different variables. Different variables, these are actually soil enzymes. So you can take any variable. Here in this case, they are soil enzymes, and people wanted to see what is the relationship between acid phosphatase, alkaline phosphatase, and acid phosphatase, or FDA and DHA, or among themselves. Are there any relationship between these enzymes in the soil? See, it has got very wide umbrella. You can test so many things here, and it will give you fantastic results. And n minus 2, you remember it is more always n minus 2 for seeing the R table, correlation coefficient table. So will you be able to do it or not? I don't know, but
Sir, from this data, we only have to calculate the correlation value.
yeah, this is correlation between two variables, any two variables.
Yes, sir, but we I want to say that we only have to calculate correlation value only,
Only
or if only correlation value, or we have to make star on it, on that value.
yeah, value we need to write star only, and on the bottom side you can mention the level of significance. That for 1 star it is 5%, for 2 star it is 1%. You can give it as a footnote.
Okay, sir.
Sir, what do we use the reference value of level of at 5% level of significance and 1% level of significance from the data which is given in the previous slide, sir? That is 0.708 and 0.536. These are standard, sir.
This is means for 10 degrees of freedom. This is for 10 degrees of freedom. These are the values. But if you
sir, if yes, sir, if degree of freedom changes, sir,
they will change. They will change. In the forenoon, I have shown you R table. In the presentation, there are 3 presentation: number 1, number 2, number 3. In number 2, you will find coefficient of correlation table, like you have T table, F table, and many other kind of tables. So correlation coefficient table is also there. I told that it is given by R.A. Fisher. R.A. Fisher made those tables, and it varies with the degrees of freedom. Degrees of freedom for error, actually, or for residual. This is degree of freedom for error or residual. So which is n minus 2 in this case. So if your pair are 7, so it will become 5. And then at 5 degrees of freedom, you will have different table value for 1% and 5%. So this is common in other also. For F table, for T table, for Z table, chi-square, you got different values for depending upon degrees of freedom and depending upon level of significance. They are never same.
okay, sir.
Is it understood?
Yes, sir. Yes.
Okay.
So one more, sir.
For sure.
Sir, in this data, there is many in this table. There is many data where there is no put upon star on that data. So what it means? Means there is no star on the data.
This table or previous table?
Previous.
This.
So what it means if they have no star?
This data?
No, sir. Next slide.
This?
Yes, sir. This one, sir.
Okay. Yeah. Your question is?
Sir, here many data or many correlation value have no star. There is no star on it.
Oh.
So what it means, sir?
It means non-significant.
These are non-significant. Yes.
Non-significant, because the values which are below these values, you are not able to, you should not put any star there. So therefore they are without a star. And you can see they are very small values, 0.382, 0.356. They are lower than these values, therefore no star. But at most, if you are interested, so you can write NS here. You can write NS as superscript. If you want to make it more attractive, more clarity, you can put NS and superscript it like you put your star. And this star can be put on the left side or right side. It does not matter, but normally people put it on the right side. In this, by mistake, I think I put on the left side of the correlation coefficient, but normally, or rather always, people put it on the right side of the correlation coefficient. Is it clear? Now this is your homework.
Yes, sir. Sir, what about last line, sir? 0.702. What about last line? The same manual or calculation in Excel. What about it?
Huh?
Sir, what about it, sir? The last line 0.702 manual calculation.
It is nothing for you. Nothing for
Okay,
you.
sir.
This is for my work.
Okay, sir.
So this you try yourself, try your hands on in Excel yourself, and now again these are the results of your homework. You will find data like this, and then you can do very fantastic relationship between all these. Suppose I applied phosphorus. What are the changes in different enzymes? What are the changes in levels of phosphorus in soil? What are the changes in the plant? So you can plot all these. You can see correlation for all. You can see regression for all. That is really very, very fantastic subject. And I tell you, these days people are talking about models. Lot of models are coming up. Crop modeling, soil modeling. Everywhere you will listen model. I tell you, models are nothing. They are based upon regression equations. So if you want to develop good models or any model, you should have basic and fundamental knowledge of correlation and regression. If you don't have, you can't do anything in modeling. So these models are also different forms of regression equations. Variety of, this is very fundamental, basic. And then when you go to the advanced stage, this regression analysis becomes your modeling. I tell you, I forgot to tell you, but these are all models actually. Somewhere I told you, you can call it equation, you can call it model, you can call it by many names. So what we are doing, it is also modeling, dear. You can add some more thing to it. So this is homework. This is exercise in class. I want to show you. Here you have K application rates. This is your X and on Y. It does not matter whether it is rice or wheat. You got some data, some figure, X and Y. So how to do regression analysis for this? So go to the data, as I told you, go to the data. In data, you got data analysis tool pack, and you click there and you will find regression. Last time I have shown you correlation. Both are available in this. So you go for regression and click OK here. Click OK. And now you need to put input Y range. Y range is your dependent variable. Variable you consider as dependent variable and minimize it so that you can enter the Y. And this is the data. You should enter in the input Y range, dependent variable. Then likewise, you have minimized it, input range Y. You select this one, and then maximize it again. So this selection will come here. It will be your cell number, your different cell numbers, row, column, etc., dollar, etc. And then you maximize by clicking here. Then you will have this kind of window. This is already selected in this part. Now the next is input X range. So this is your X. You want to enter this here. So click to minimize it, the input X range. Now this is your minimized. So first is your after minimize, select the data to input range. So this is the input range. This is for X. Select it, it will come here, and then you maximize it. Again, click it here, it will be maximized. So it will be maximized here, like in correlation you did it. So here the data is entered. Here you can, if in the first line, you got some labels, you tick it, and confidence in level is already fixed. It is 95% or 5% level of significance. Number 2 is click on the output range. Output range, you remember where you want your result. I have shown in correlation how to do it. And then you minimize it by clicking here, and then it will be minimized like this. Instead of correlation, now you are seeing regression. And then number 1 is minimized output like this. Number 2 is select the space. Here you want your result. And then again click here to maximize it. So 1, 2, 3 is there. If you want to learn by using these guidelines, you can do it. So these days, students and people learn from the manuals are given and you can learn. So then it will appear like this. And now you want to get residuals also. So residuals, I think I already told you, these are the differences in observed and predicted values of the parameter, dependent variable. So tick the residuals. If you want residuals, you click here. If you want residual plots, click here. If you want standardized residual, click here. So what is happening now? One more science is coming for residuals. Now many scientists are writing papers based upon the residuals, the data that could not be fitted. Only that data, and again regression analysis. You would surprise to see that how wider this subject is. So tick the residuals, and normally residuals are thrown, you know, residual in your soil science chemistry. When you filter the substrate, you keep the filtrate, and remaining thing which is kept on the filter paper, it is thrown. That is your residue. But here in statistics, residuals are very, very important. Now you see, when you click it here, click OK. So it will give you result. I made this, I just copied from the Excel file and make it colored to make you understand. So such kind of results will be there in the Excel. When you click this, and from this we can make the equation. First of all, you will see that this Excel gives you multiple R. This is actually correlation coefficient. Correlation coefficient between two variables that you have taken. And what variables you have taken? These were two variables. This X and Y. So this correlation coefficient is between X and Y, 0.992. Then R square. You can square this value. This is coefficient of determination. It is given. And then you get adjusted R square, standard error observation. Just you forget this. This is not for me and not for you. This is for a statistician to make use of this. I do not know anything about this adjusted R square and so on. So I know that what is this multiple R is your correlation coefficient and R square is your this coefficient of determination. Okay. And then ANOVA is also given in the results. So in ANOVA, you can see regression. So because we did it for linear regression, we did not did it for quadratic regression, we did it for linear because there are two variables. One is X, other is Y. There is no X square here. If you put one more variable X square, then it becomes quadratic. So now you see regression, degree of freedom is 1. When you have linear relation, degree of freedom is 1. When you have quadratic, this is 2. And total is n minus 1. So in this case, you got 4 pairs. So 4 minus 1. So 3 is the total. And for residual or error, 3 minus regression degree of freedom, that is 3 minus 1. So it gives you degree of freedom for residual. Then sum of square, if you remember manually, we did it. Sum of square for regression or linearity. Sum of square, total sum of square, summation is small y square. And then you got residual by difference method. So this total sum of square minus this you get for residual. Then mean square. All the sum of square are divided by respective degrees of freedom. You get mean square. So you do it manually. You can also do it manually. You will find exactly the same answer. Then F calculated. This is F calculated. And this is your mean square due to regression divided by mean square due to residual or error. So this divided by this, you get F calculated. This is F calculated, which is significant at, you can see this, just forget this. You do not bother about this part. You do not bother about this part. Now you see significance, whether it is significant or not, whether your equation is linear or not. So here, this is the significance level. Means you multiply it by 100 and that will be your level of significance. Remember, you multiply it by 100. So if you multiply it by 100, then you will get 0.71%, or you can say 0.72%. So your equation is significant at 0.72%. What does it mean? If it is significant at 0.72%, that means it is surely significant at 1% or higher level of significance. So we can say with certainty that it is significant at 1% as well as 5%. And now the other thing is that value of intercept is also given here. Coefficients, you see coefficients. So first coefficient is A, which is known as intercept. Value of A is 3.06, and this is B, regression coefficient, and this is 0.0305. So you place the value of A and B here, and this is your linear equation. Same way you calculated value of A and B when we understood it manually. So you got it. Now, next is your residual plot. It is also given. These are the predicted values, and original values are these. These are your original value. These are called as observed value. These are your observed value, and observed values minus predicted value. Those values just I shown you, minus these values makes your residuals. Means this is very small fraction of the data, which is not part of the equation, which is not represented by the equation, which is your error. Now, next is plotting the equation. So we will plot it. The last session is left, and that I will start. The third and last slide, link for today. So kindly go to the third link. I know you must be tired, but I would like to finish it here. Last session. So now plotting the equation. Now you got the equation, and one point I just forgot to tell you. So testing the linearity of the equation means exactly we are testing the regression coefficient B. We are testing the regression coefficient B. I just went advanced slowly. First I said you it is equation we are testing. Now I say you what test through F test we are testing the significance of not of equation actually. We are testing the significance of the regression coefficient B, whether these values are significant or not. If these values are significant means our equation is significant. Remember this point also. So you can see the significance here level here for regression. This is for regression coefficient in fact. And you can see this line. In this line, this value, P value. This P value is for the regression coefficient, which is your B. And this is the significant level for A, your intercept. A. It is also significant, but it is significant at 1%. Not 1%, sorry, it is 0.1%. You multiply this value by 100, so you get 0.1%. Whatever I am speaking, whatever I am teaching you, everything is correct. There cannot be mistake. There is no chance of mistake in this part. Believe me and trust me, and according to that you follow it in your life. You will be happy to follow it, because it is not there in the books that you multiply it by 100 to get level of significance. But it is truth I am telling you. These things are not explained in the softwares. So now you see how to plot it. Plotting is also very interesting and very easy. So suppose this is your data, X and Y, just you have seen the same data, you can select it and you need to insert a chart here. So you go to insert in Excel, you usually make your chart here and go to this section chart, and here you want to make figures, etc. You will find a scatter plot here. So click on the scatter, and there are many options. So click on this option, scatter. And when you click on this option, you will get this kind of a figure. Scatter plot. This is your scatter plot, and these are different points. Different points. These are the points. 3, 3.8, 4.2, 4.9. These are the point on this equation. For example, it is 3. At 0, it is 3. At 20, it is 3.8. At 20, it is 3.8. So these are the points from Y. And now you need to join these points. You cannot join them. You need to have a line, regression line. So how to get it here? Or which is also called as a trend line. In Excel, they refer it as a trend line. Regression line is called as trend, T-R-E-N-D, trend line. So now you select the data. If you click on one data, all the data will be selected. And then right click on the any one data. Any one data, you can right click, and then you will get this kind of option. This pop-up will open, and here you find add trend line. Click here. Click on the trend line. Then you will get, when you click on the trend line, you will get this kind of pop-up window again on the right side. And then there are many kind of equations you can fit. You can fit exponential equation, you can fit linear, you can fit log equation, polynomial, power, moving average. There are so many options here. So suppose we assume, because in our case, it was a linear equation. So we must fit the linear plot. Linear graph will be made, linear line will be made. And now we cannot go for other equation because linear was significant. Just now we have seen. Click on linear, and on the bottom side, display equation on the chart. Tick here. Display R squared value on the chart. Tick here. You tick on both places, and then you will get the equation. Then you will get the line. So this is your line. When you click here, display equation on the chart, automatically you will get here. You will get equation y is equal to so, R square is equal to 0.9857. Same equation, you see? Same equation what you get here, 3.06 plus 0.30. So same equation, what you get from regression analysis, same equation you will get on the figure here. Same equation on the figure and same R square. So I think plotting of the equation is clear to you, and we'll see how the quadratic can be plotted now. Any doubt, any question in this? Any problem in this? Shruti, any problem?
No, sir.
Okay. Clear? It is very easy. But we should know why we are doing it, what is the basis of doing it, and what is the interpretation. What is the meaning of this? If we understand this, then we can rightly apply regression. Otherwise, in the Gomez and Gomez book, I recommend you to read one chapter, Uses and Misuses of Regression. One chapter is also there to help you. Uses and misuses of regression. Many times people misuse regression also. They give wrong information through regression also. So it has been a subject. Now, one exercise in the class, I can show you about this. Soil pH is there, 8.58 and so on. It is decreasing. Soil pH is decreasing and phosphorus also P is increasing. Now, don't ask me question why it is happening. I'm not teaching you fertility here. It is statistics. It is your fitting the equation. So perform the regression analysis in this case. So you can do yourself also. Perform the regression analysis. Data, you can paste the data and then go to the data. You remember data in your Excel, then to the data analysis, then to regression, then enter input Y range. This is the next step. Enter input X range. Select the area for data output where you want to put your data results and click OK to get the ANOVA and other details. So this is very simple. You can do it. These are the steps given to you. And you will get this kind of output, correlation coefficient, R square, and then residuals. So residuals you can calculate. This is your actual data. 6, 9, 11, 14, 16. I took it from here. This is your exact data, observed data. And now I want to tell you what is residual. So this is your observed data and this is your predicted data. Means in the equation, I have not shown you equation here. Yeah, this is the equation. This is the equation. In the equation, if you put this 6 is the actual data, 6 is the value of X. And if you put the 6 value here, 6 value here, then you will get the predicted value. Then you will get the predicted value, which is 6.2. In the equation, if you put 9 in place of X, you will get predicted value 8.7. But this Excel has given you automatically, but you can get it manually also. And residuals are very small. You can see very small. Out of so much, residuals are small fractions. So you will get this this kind of results. And A, B, I already explained you. 48.7 is your A. B is minus 5x. This is in minus, you see. And it is significant at 0.014%. And if you want to make the predicted values, for example, this 48.7 minus 5x. So in place of x, you can put the 7.2, which was the original value, and you can calculate 12.7. Similarly, you can make prediction for other way around also. Suppose you want to know, though it is not allowed, but you can try other way around also, that if your Olsen P is 12, what will be the pH of the soil? You can do it legally. You can do it legally. If you have 12 values of Y, so in place of Y, you can put value here and you can know the X. You can calculate the value of X. So you can do either way also, predictions. So then you need to make a chart from this, select the data, click on insert, I have shown you in chart, click scatter, select the data points like these data points, right click, add trend line, then go to trend line, select linear, click display, equation on chart, click display R square on equation, get the following. So you will get these equations. You see, it is showing negative relationship. And you can give the name of the figure. Name of the figure, you can write relationship between soil pH and Olsen phosphorus. Relationship between soil pH and Olsen phosphorus. So this will be your title of the figure. Now fitting quadratic equation.
Voice is not.
Yes.
Yes, sir. Now his voice is okay.
My voice is not audible.
Audible, sir.
Here, okay. So now you are fitting the quadratic equation in Excel. This is another fresh example. X and Y. This is last example. And maybe in next 15-20 minutes, I will finish it. X and Y, you got 6 or 4 levels of say nitrogen or phosphorus, whatever you want. And Y is your yield in ton per hectare. Now here you are going to fit a quadratic equation. I have already tested that it is not a linear relationship. Therefore, straightway test whether the data shows quadratic relationship or not. Test the significance of the significance by regression analysis, plot the equation, and then once you have plotted the equation, you can work out the economics also, like I have told you in the last example. So what you need to do, perform the regression analysis. Here we need to create a variable x square. This is important. In linear, we did not create a new variable, but here you need to create new variable x square because there are 3 terms now. And then same way you can do it, data analysis, regression, go to regression, enter input y range, enter input x range, select both x and x square. This is the important point, that when you enter input X range. Here you need to select X and X square both. It is problem only in the Excel program. If you do it in SAS or any other software, you need not to create this variable X square. You need not to create it. In that case, only XY is enough. But in Excel, if you are fitting quadratic equation, you need to put this extra variable. If it is cubic, then one more column, you can have X power cube. And then fourth column will be by Y. So here it is necessary if you are fitting quadratic equation. This must be remembered, otherwise you cannot fit quadratic equation in Excel program. Now you go to the input Y range. Input Y range, you can minimize here, and select this. Select this. And then you will be going to input X range. Minimize it and select both X as well as X square. And X square can be calculated by squaring this column. 60 into 60, 3600. 120 into 120, 14400. And 180 into 180, you get this. Now, and then you can output range, minimize it, you will get output range here, and then click OK. So you will get these kind of data. Summary output means this is for your correlation coefficient, this is your R square, and forget about these. And then this is your residual. These are your observed data. I have just copied Y data. This is your Y data, this data, Y data, actual data, and predicted data. This is given by the computer. Your values, you can put these values in the equation, these values in the equation, and you can find out the predicted value. And difference of observed and predicted is your residual. Very small quantity of data is there. Sometimes in Excel, you find like this. Many students may not be knowing the meaning of this. This is your, this kind of thing is there. 4.44E-06. What does it mean? That means that that decimal place has to move 6 places to the left. Decimal place has to move 6 places to the left. That is the meaning of this. If you convert it into the values, it will be like this, 0.000004. So it has moved 6 places, this the decimal point. If it is 2.06E-17, it means 16 0 before 2 and then decimal on the left. 16 0 before this 2. I think you understood the meaning of this. So you get this ANOVA for quadratic relationship. So here, sources of variation, you know about linear. Similarly, in this case, for regression, degree of freedom is 2 because it is quadratic regression. Automatically, it will come. Total pairs were 4, 4 minus 1, it gives you 3. And then 3 minus 2 for error, 1. And then sum of squares, mean squares, you know how they come. And then F calculated this mean square regression divided by residual, you get this degree of freedom. And it is significant at, you multiply this value by 100. So it is significant at 3.3%. Then it is also significant at values higher than 3.3%. But it is non-significant at values if you lower this less than 0.31%, less than you multiply it by 100, 3.31%. So it is significant at 3.31% or at higher level. And then you can see the intercept A is 2.13. It has come, and B 0.025667, and C has come out to be minus 9.4 E. So C value most of the time in fertilizer data, when you fit quadratic equation, comes in minus. So here 9.4 E-05 means this decimal has to move 5 places to the left, and then you can put 0 before 9, 4 0 before 9. So equation is y is equal to 2.13 is your intercept, plus this is your B, and this is your C. Now plotting the quadratic equation, same way, just now you have seen for linear. So same way you can do it. You can go to the chart, scatter plot, and then you will get these dots, go to trend line. In trend line, you will get this option, polynomial. Now you go to select the polynomial, and if you want quadratic, select 2. If you want cubic, select 3, and so on. And on the bottom, display equation on chart and display R squared. So you get this equation. You already got it here. You already got it here. And this is your original data. So fitting of the equation, this plotting of the equation is also done in Excel. Now, this is just one example. I have already solved it. So these are the data. I think it is the same data or different. For this is different data. So in this is your regression equation. R square is 1 for quadratic relationship. R square is 1 means all the points, this line is passing through all the points. There is no, practically there is no residuals, there is no error. So this is one of the best fit, So then you can go for economic analysis. This is the equation. And from this equation, you know value of A, value of B, value of A is this, value of B and value of C. And you know Q upon P minus B upon 2C. You can work out the optimum dose. I have given you example. And this is the way to make a presentation. When you have formula and when you work out the optimum dose, suppose you are writing it in your thesis, then or research paper, you can write in this tabular form like maximum yield dose, formula minus B upon 2C, calculations or answers, optimum dose, response, and all these things can be written like this. Please try to study it in your free time. This is your homework, and the problem is given here. You can try your luck and whether you can solve it. And this is again homework. You can try this example. And second last point, important point is that many times you will come across that a particular data, when there is no statistical procedures are followed, when students just make the data, construct the data, produce the data, or when they do not record the data correctly, when there is a problem in the randomization of treatment and taking the random sample, then many times your data is not good. Then what problem comes that both the quadratic and linear relationship may be significant. One data you will come across in future in your life, that one data is giving two kind of result. It is showing that it is linear, and it is also showing that it is quadratic or cubic. So many times such things come when your data is not recorded properly and data is artificial, then you may have problem. That is why I told you uses and misuses of regression. So we need to follow all the statistical procedure, then we will get good result. Otherwise, sometimes this regression can be misleading also. I am telling you some limitations of the correlation and regression analysis. And you can see in this case, the data is same. But in this case, you can see that this was also significant. On the top, I have fitted linear equation. So it was also significant, and R square was 0.8672. On the bottom, you see I have also used this quadratic equation, and then it was also significant. But you see the value of R square is higher. And here also you see that the curve is very close to the data. Curve is very close to the actual data. But in this case, you see this line is somewhat away from the data. It is not a better fit. but it is giving a better fit. First, you need to see the line, and then you consider the value of R square. So here the value of R square is more. So in this case, if it is compulsory to show you this regression analysis, then instead of linear, I would prefer that you go for quadratic kind of relationship for this data. So such problem also come in regression analysis. And you can see here, multiple correlation coefficient in one case. When you have fitted the same data, it was 0.93. And here it was 0.999. So quadratic was better because your multiple R is higher here. R square here is 0.86. Here in quadratic 0.998 or almost 0.999 you can say. And then forget about others and see the significance. So it is significant at 6.8%. Okay, close to 5%. So I think in this kind of data, I was thinking that it is significant. So here linear is non-significant. Linear is non-significant because it is significant at 6.8%. But if you see this quadratic relationship, it is significant at 4%. So I think we can go in this case for quadratic relationship because linear relationship is non-significant. But sometimes you will come across when your both the results are significant. In that case, you can see R square. R square higher in the case in that will be okay. That will be better choice. Now this is again one exercise for you. Here the equation is given. Equation is given. Rate of input and price of output is also given. And then you need to work out this. I have already given you example. Those who are interested to practice can practice it and learn it. It is up to you. And this is example. And this is the last slide for today. Last slide.
Sir,
yeah.
One thing to help, sir.
Yeah, you can ask many things.
Here in this question, what will be the price ratio, sir? Is this 10,000 divided by 10 or 10 divided by 10, sir?
Very good. So this I gave intentionally. Many times students do mistake in this case. So remember,
Yes.
remember.
Yes, sir, this is.
Yeah, I got your point. You all should remember that whatever units have been used in the equation, the same units will be used in price and cost. For example, in this case, this is the equation. Can you see? I just selected the equation y is equal to 2.023, 0.0302x, and so on. Can you see it? Equation.
Yes, sir.
Yes, sir.
Okay. So in this equation, x is given in kilogram. When I fitted this equation, x was given in kg per hectare. So rate of x will be for 1 kg fertilizer, because x is your fertilizer input. And in the bracket also I have written. But if I give it in the exam, I will not give you the things which I have given in the bracket. So in the bracket, you can see it is given in this equation, the yield is in ton per hectare. So you have to give the Q upon P, price of the output in ton per hectare. You need to write 10,000. This is very simple. In the equation, if your data is in tons, so you need to give the rate in tons, price in tons. So 10,000 will be used in place of Q upon P. In place of P, 10,000 will be used. In place of Q, 10 will be used. Okay, so in examination, if I give you price of 1 kg rice is ₹10, then you need to write 10,000, because in the equation, your Y dependent variable is in tons. If it is in kg, so this is kind of confusion sometimes comes. Is it clear now?
Yes, sir.
Okay. So if you get the equation, maximum yield dose, you can calculate. Equation is given here, minus B upon TC, 2C, optimum economic dose, estimate the yield at 50 kg. you have the equation. You can estimate or predict the yield. Just you remove x by 50. In place of x, you put 50. In place of x square also 50 square. Remember, it will become 50 square. 50 into 50 you can write. And then response at optimum. I taught you already all this. So you can use that to learn it. Any other question? Any other question in any part? Okay, this is last slide I'm going to show you. Zinc enriched urea improves grain yield and quality of aromatic rice. And this, in this, I want to tell you how to calculate the economics of fertilizer. Fertilizer economics, only one table will be enough. And in other cases, you have seen the optimum dose of fertilizer. Here you can see maximum return per rupee invested. This is another dimension of calculating the economics of the fertilizer. And it was from my favorite student, Dr. Gulab Singh Yadav, who is no more. And I pay my tributes to him. He was very good scientist here. Last year, he died in Corona, and my tributes, my respect to him. He's no more. His younger brother is Subhas Babu in our department, who is also scientist. So you can see this was his work. And in this case, it is very simple to calculate the economics of fertilizer. In the first case, you can see just treatment. Or you can say you need not to bother about this treatment. See the next column, zinc rate kg per hectare. So these are the rates of zinc fertilizer application. It is just zinc fertilizer application, and you can consider it as a variable X. You can consider it as a variable X because the doses are changing. Doses are changing, and grain yield, this is the response. When you have 0 zinc, 3.98. When you have 1.3, these are the responses in terms of grain yield. And then agronomic efficiency can be worked out. For any nutrient, any fertilizer nutrient, you can work out the agronomic efficiency. Means kg increase in yield due to unit application of fertilizer. So in this case, suppose you apply 1 kg of zinc, how much increase is there in the yield? So if you remember the formula of agronomic efficiency, yield at treatment minus yield in control divided by fertilizer rate. So here you get 4.25 for first treatment, 4.25 minus 3.98, and that can be divided by 1.3. So you get 208. So this is your agronomic efficiency of zinc, kg grain increase per kg zinc. So 208 means 1 kg zinc is giving you 208 kilograms of grain. So this is the 1 kg zinc. Now you can calculate the price output, price of this economic product, that 208 kilogram extra rice grain you received because of 1 kg zinc. So you can calculate the price of this 208. So you can see price, it is very old data. It is 2006 or 5. So you can see that time procurement price was 6.1. In 6.1 rupees, you could buy 1 kg rice for government. So 6.1 multiplied by 208, you will get the price of the output, the value of the output in terms of money. So there 208 multiplied by 6.10. This is the rate of the grain for 1 kg. So what will be the rate for price for 208? Now similarly, you need to work out the cost of the input. So here you have 1 kg zinc, because 1 kg zinc has given you 208 kilograms of grain. So therefore, you need to know the cost of 1 kg zinc. So cost of 1 kg zinc is 95 rupees. That time it was 95 rupees. So you divide 208 by 95. You will get 13.3. You will get 13.3. Then 4.44. 4.44 minus 3.98. Then you will get 353. And this again divided by 95. Similarly, for next data, you can calculate these agronomic efficiencies, and you can see the economic return rupees per rupee invested in zinc. So this is very partial economics, but it can give you some idea that how we can calculate this kind of economics, and this will add some value to your thesis, to your research paper. And because of this data, this paper was published. So anyway, this ends discussion here, and your questions are welcome. And I can also stop the recording.